All right, here we go with the graphs of polynomial functions. What we're looking at here is the graph of this polynomial. And what we want you to really pay attention is we have two factors here, x plus 1 and x minus 3, which is squared. Now what that relates to is, well, we know that they're going to be the zeros. So here is my 0 at x is equal to 3 based on this factor, and this is my 0 based on the x equals negative 1. So what happens is, dependent upon how many times a factor is repeated, like in this case right here, this x minus 3 is squared. It behaves differently than something that isn't repeated. So that's what we're going to look at. First thing we're going to talk about is multiplicity. So in this above example, the x plus 1 has a multiplicity of 1. So the 0, x is equal to negative 1, has a multiplicity of 1. And up here, the 0 of x is equal to negative 3, it has a multiplicity of 2 because it's squared. So if we look at multiplicities, all of these have a multiplicity of 1. They go straight through the x-axis. They don't do anything funny there. So that's a multiplicity of 1. And if I have something with a multiplicity of 2, it actually bounces off the x-axis. So we consider that a point of tangency. So it hits it at one point and it bounces off. And anything with a multiplicity of 3, it has what we call a point of inflection. So it goes through the x-axis, but it doesn't bounce off and it doesn't go straight through. So this is, again, point of inflection. So let's take a look at some definitions. First, tangent. Come on, there we go. A polynomial graph is tangent to the x-axis at a point where the graph touches and does not cross through it, but it does have a 0. We consider it a 0, touches at one point and comes off. Next is the point of inflection. A polynomial graph has a point of inflection on the x-axis if the graph changes concavity at a point on the x-axis. So that's how we get this shape right here, or this shape right here.